I can add, subtract, multiply, and divide rational numbers. So we're talking about positive and negative, whole numbers, decimals, fractions. Okay. So fraction addition. So we have to have a common denominator, which if we have a third and a half, our common denominator is going to be a 6. A third and a half. Okay. Our least common multiple is 6, so this is going to be times 3. So this is 3 times 2, so this is 2/6. So I've got a negative 2/6 plus 3/6. Well, if I have a negative 2 and a positive 3, I end up with a positive 1/6. Number 18, again, common denominator, we're subtracting. So I have a fourth and a 12th. So I need to turn that fourth into a 12th, the common denominator. So it's times 3 times 3. I'm going to rewrite this problem with common denominators. Negative 3/12 minus a negative 7/12. So removing negatives is the same as adding. Big plus. Okay, subtracting a negative is the same as adding a positive. So I have negative 3 plus 7. That's going to be 4. And it's 12ths that we're working with. All right, we really should reduce this. We can divide both of these values by 4, which is going to give me 1/3. All right, this is negative 2.5 times 4. So let's see, a 2.5 times 2 is 5, and then double that, that's going to give me a 10. And I know my answer needs to be negative. Okay, a negative times a positive. Or if you want the standard algorithm, you could do that. 4 times 5 is 20. 4 times 2 is 8. 9, 10. And we need to put the decimal here because there was one decimal there. So I have 10.0. But we have to go back to the original and notice that it was a negative times a positive. So my answer is going to be negative. Now here, we need to convert these into improper fractions. So this is going to be 4 times 1 and then add 3. So that's 7/4, negative 7/4. Divided by negative 4/5. Remember, when we divide fractions, we need to multiply by the reciprocal. So the first fraction stays the same, and we're going to multiply by the reciprocal. Reciprocal just means to flip. It doesn't change the sign. So we still have a negative divided by a negative, which is going to be a positive number. So we're going to have 7 times 5. 4 times 4, and we know our answer needs to be positive. Negative divided by a negative is a positive. And now I know that 16 goes into 35 2 times with 3 left over. 2 and 3/16. Right? 16 into 35 is 2 with 3 left over, 3/16. All right, number 21, straight up subtraction. So negative 5 minus a negative 3, removing 3 negative tiles is the same as adding 3. Negative 5 plus 3 is negative 2. Okay. Now I have 6.2 plus a negative 5.4, so we're taking 5.4 from 6.2. So that's going to be a 0.8. And here we have 3 1/3 times 2 3/5. So we need to turn these into improper fractions. So 3 times 3 is 9 plus 1, 10/3. 5 times 2 is 10, plus 3 is 13/5. We're going to go ahead and multiply. Now, to make our lives a little easier, we can see if we can cross-cancel it all. 3 and 13 are both prime numbers. We can't reduce those, but 5 does go into 10. So 5 divided by 5 is 1. 10 divided by 5 is 2. So now I have 2 times 13 on top. and 3 times 1 on the bottom. 3 divides into 26 8 times with 2 left over. Right? 3 into 26, that's 8, with 2 left over, 8 2/3. All right, now this one, let's see here. We have 2,000 times 0.002. Sorry about that. All right, so we have 2,000 times 0.002. All right, so I have 2 times 0, 2 times 0, 2 times 0, 2 times 2. I'm done. At this point, I just need to move the decimal 1, 2, 3 places. 1, 2, 3. So my answer is just 4. The other way we could think of this problem is it's 2,000 times 2. This is tenths, hundredths, thousandths. 2 thousandths. Turn this into a fraction. Put that over 1. 1,000 goes into 2,000 2 times. 2 times 2 is 4 over 1 times 1. And you still get 4, no matter which way you do it.